Hey guys, welcome to Civil Engineers Adda. So today we are going to see the second part of a moment area method where I am going to introduce principle of superposition. So what is principle of superposition? Here the effect of given combined loading. So in the meaning, if there is a combined load, more than two loads are given. So suppose in the same problem you can explain there are 2-point loads here. So the effect of given combined loading on a structure may be obtained by considering the effect of each individual load separately and combining the results obtained. Means if there are two loads that have been given, we have to separately calculate for each load. We have to separately get the bending moment diagrams and all the values at the last we have to combine to get our desired result. Okay, so let us understand this concept by solving a problem. So the cantilever beam, determine the slope and deflection at the free end. Flexural rigidity is constant. So the flexural rigidity is constant. Now let us start the problem. So first I will take the let us draw the cantilevers. Let me show the application of superposition here. So this is the cantilever here. So the entire cantilever is being divided into two parts, so B and C. Now what I am going to do, the first load is 5 kilonewton. So only that load will be taken in figure 1. In figure 1, and let me call this as figure 2. Only 5 kilonewton will be taken. Second part is we have to take only here 2 kilonewton. That is what the principle of superposition is telling. That is, if there are two loads, individually you have to take those loads at their respective positions and then draw the bending moment diagrams and then combine the results. So I need to combine, so I am using plus symbol. Means this both diagrams will always will give you the original problem itself. Okay, so now let's go for the bending moment diagram. So let me draw a straight line here. So I am drawing a bending moment diagram. So at the center, let me mark some points here. So similarly, just draw a straight line. So I may mark points here. Then calculate so this is 3 meters. So 3 everywhere here. So 3 meters. So now bending moment diagram, bending moment value 5 into 3, 15. 5 into 3 is 15 kilonewton meter. So this is 15, which is nothing but 5 3s are 15 kilonewton meter. Okay, let me write even the unit here. So minus sign. Okay, similarly here you can see the 2 kilonewton is acting at the free end. So now the bending moment value will, what it will happen, 2 into 3 plus 3. Okay, so it will be, let me draw the nature of the bending moment diagram will be linear part. So this is linear part. Just I'm doing it because in my diagram it may look little bit curved also. So linear part, again minus. So what will be the value? 2 into 3 plus 3. Okay, 6. 3 plus 3, 6. 6 2s are 12 kilonewton. So 12 kilonewton meters. Okay, fine. So these are the bending moment diagrams for the two beams considered separately. Now what we want? Now we want the slope and deflection at the free end. So for that you need to consider the centroid. You need to consider the centroid of this. Now at the free end you have to take the value up to the free end. So figure, distance here should be taken as 3 2/3 of 3 plus 3, which is how much? So if I want to write this again, so 2/3 of 3 plus 3. So 3 gets cancelled, 2 plus 3 is 5 meters. 2/3. So 2/3 of, again you have to consider here, 2/3 of 3 plus 3 is 6 meters. Okay, 2/3 of 6 is the distance. Same thing again, distance will be same here. So that is also again 4 meters itself. Now let us obtain the first, we will obtain the slope. Okay, we will obtain the slope at free end, at C or free end. So let us call that as theta C. Okay, so theta C is equal to theta CA, which is nothing but change in angle between the tangents at A and B, or it is nothing but moment of M by EI area between, moment of M by EI area between AC. Okay, M by EI area between AC. So for this, what we have to do is half, what is the area? What is the area of the triangle here? The area of triangle is half base. Base is what? Base is 3 into height. Height is 15. Okay, divided by EI. Divided by EI. Plus, because this is a combined effect here, individually we have to consider. So next, plus half into base. Now base is 6 into height. Height is 12. So 12 divided by EI again. So let us add both of this. So 15 3s are 45. Okay, 45 by 2. 15 3s are 45 by 2 EI plus 2 1s are 2 3s are 12 3s are 36. 36 by EI. So when you solve this, what you get here will be 58.5 EI. 58.5 EI. So the theta C value here, the slope is 58.5 EI. Okay, now you can substitute the value here, 58.5 divided by the given value of EI is 12,000 kilonewton per meter square. So this is 12,000 kilonewton per meter square. So you will get 0.27 degrees. Okay, 0.27 degree is the slope. Okay, so now we need to calculate the deflection. So second part is we need to calculate the deflection at free end. Deflection at free end. Okay, so let us call that as YC because it will happen at the place C here. Okay, there's a C here, so the deflection will be C. So actually what will happen, this beam will try to bend in this way. Okay, so when it happens in this way, so the distance deflection will be YC and this will be theta C. Okay, slope. So now let us calculate the deflection. So formula for deflection already given. So YC, or even you can say delta C, is deviation of C with respect to tangent at A, or moment of M by EI diagram. Moment of M by EI area between AC about C. About C is very important. About C. Okay, moment with what distance you will take, moment of M by EI area between AC about C, very important. About C is very important. So now again the moment, already we are having the area here. We already have the area for the first diagram. So we will just multiply that area value here. Distance here should be taken as 2/3 of 3 plus 3, which is how much? So if I want to write this again, so 2/3 of 3 plus 3. So 3 gets cancelled, 2 plus 3 is 5 meters. Let us multiply by 5 meters. So this value will be 256.5 EI. 256.5 EI. Okay, now substitute the value of EI 256.5 divided by 10,000. So what's the value here? It is 0.0214. Okay, 0.0214 meters. Okay, this much meters, or even I can say it as 21.4 millimeters. Okay, 21.4 millimeters. So finally we got the slope theta c is 0.27 degrees and the deflection yc is 21.4 mm. Okay, so I hope you understood the method of principle of superposition. What you need to do mainly, to summarize the thing, the individual loads need to be considered and their individual bending moments need to be drawn, and there where the slope and deflection is asked, with respect to that you need to calculate the distance. And so lastly, slope formula is m by ei, area between A and C. Next, deflection formula is moment of m by ei, area between AC about C, because moment is force into distance about C. Okay, now I hope this is clear. So I will